Now let's do another circuit from the dot convention or coupled circuit analysis. Here again we are having a circuit, but here we can note that there are many dots. There can be as many number of dots showing a relationship between different coils. For example, J2 and J6 are related by a mutual inductance of J3. Similarly, J2 and J5 are related by this square dot with a mutual inductance of J4. Similarly, J6 and J5 are related with this triangular dot with a mutual inductance of J3. For each and every case, we will have to draw a dependent circuit. So let us first start by drawing the circuit again. Now I have left gap for these two dots here, and for these two dots on either side of J6, this one and this one, I have left the gaps here, as well as for these two dots under J5 I have left the two gaps here. And we all know that in each of these gaps there will be a dependent source that has to come, and only need that we have is that we have to mark the polarity as well as what is going to be the value of each of these dependent sources. So let me draw the dependent sources first. The dependent sources are here. Now the current, let's take the first dot as the circle. So the current I1 is entering the dot, entering the coil J2 at this dot. So at this dot it should be leaving. The current should be leaving. So here the current, if it has to flow in this direction, then this should be negative and this should be positive. Because the mutual inductance is J3, I will write J3, and the current that was flowing in this coil was I1, so J3 I1. Similarly, let's take the case of these squares. I have to take the other way around also. So the other side of this one, if I'm going to consider the current as I2 here, then I2 is entering this coil J6 at this dot. The current is entering, I2 is entering, so here it should be leaving. If it is leaving, then it has to flow in this direction. It has to flow in this direction, that means outside of J2. So this is negative and this should be positive. And the value of that will be again J3 is the mutual inductance, so J3, and the current that is flowing there is I2. Similarly, let's take the second case of these triangles. So here the current that is flowing in this coil J5 is I1 minus I2, and it is leaving the coil J5 at this triangular position. It is leaving the coil. Since it is leaving the coil, here whatever is the current should enter the coil. That means current should enter J6 from here. So this should be positive and this should be negative. Since the mutual inductance is J3, so I will write J3, and the current that is flowing here is I1 minus I2, so I1 minus I2. The same thing I have to write here. So here the current that is flowing in J3, so in J6 coil is I2. I2 is leaving from this. I2 is leaving this triangle. If I2 is leaving this triangle, then it should be entering the coil J6 at this triangle. So if it has to enter at this point, if it has to enter from this J6 at this particular point, then this should be positive and this should be negative. And the value will be again mutual inductance is J3 and the current that is flowing is I2. Similarly, if I have to go for these two, let's take first one here. Current I1 is entering this point. So here at J5 it should be leaving. If it should be leaving J5, it should be leaving, then this should be positive, then this should be negative and this should be positive, and the value mutual inductance is J4 and the current that was flowing in the other coil was I1, so this will be I1. Similarly, if I am going to look at the current that is passing through J5, it is I1 minus I2 is leaving the coil J5 at this dot, square dot. So here it should be entering. If it has to be entering the coil, then this should be positive and this should be negative. And since the current is, mutual inductance is J4 and the current flowing is I1 minus I2, so the value of this dependent source will be this one. So now we can write the rest of the current I1 and we can write I2, and if you would write the KVL for mesh 1 and KVL for mesh 2, we will find out that the equations comes out to be, I'm not going to solve those equations, I'm just going to write the final equations that we will get when we carry out the KVL at mesh 1. At mesh 1, I will get the equation as 10 angle 0 degree is equal to minus j I1 and minus 5j I2. This is the first equation. Similarly, the KVL at mesh 2, that means in this one, remember we have to put the polarity plus minus based on the direction of this current I2. I will put the polarity and when I will write, and then when I finally find out, I just get it as 0 is equal to 5j I1 plus 5j I2. And what they have asked is to just get the mesh equations. So these are the two mesh equations that we are having. We can write them in matrix form if you wish. Let's go to another problem. This is another problem that we are having. It's quite a simple problem. Again, what we have to first do is we have to redraw the circuit. Let's redraw the circuit. So as you can see, we have redrawn the circuit, and now we need to see what all the values we have to give for this dependent source here and the dependent source here based on these two dots. So here if the current is I1 and here if the current is I2, then the current that is entering I1, that is entering at this dot, entering J4 at this dot. So here it should be leaving this dot. So if it has to leave this dot, the current should be flowing in this direction. So this will be negative and this will be positive. And the value will be J3, mutual inductance J3, and the current that was flowing in the other coil, which was I1. Similarly, vice versa, here the current that is flowing downwards is I1 minus I2, and I1 minus I2 is entering the coil J5 at this dot, entering the coil J5 at this dot. At this dot it is entering. So here it should be leaving the dot. So if it is leaving the dot, that means the current should flow in this direction. So if the current has to flow in this direction, then it should be negative here and positive here. It should be negative here and positive here, and the value will be based on J3 mutual inductance and the current that is flowing, which is I1 minus I2. So we have drawn the circuit. I1, the current I2 is here, and then we can write the KVL equations. If I am going to write the KVL for mesh 1, KVL at mesh 1, I will get the equation as 5 angle 45 degrees is equal to 3 plus 15j I1 minus 8j I2. This is the first equation. Similarly, KVL at mesh 2 will give me the equation 0 is equal to minus 8j I1 and minus j I2. So based on these two, if I am trying to use the matrix method, I will get the value of I1 as 0.063 with an angle of minus 42.82 degrees. I am not interested in I2 because what we have been asked is the voltage drop across 3 ohm resistor. 3 ohm resistor is here. The only current that matters is I1. Therefore, voltage across 3 ohm resistance is basically 3 into I1, which will give me an answer of 0.19 angle minus 42.82. Try it.